7, Product Development and Design Management. We have an interesting morning. We have Argo Picas presenting the first 3 papers, and as he just discussed, he will have a single presentation, so we'll give him longer time, and then we have the discussion after that, because these are all related to each other. And then after that we have another paper on visual planning and design by Helena. So we look forward to this session. Argo, you have the floor.
Thank you. So, good morning to everybody. So I hope once I start to see that people start to fall asleep, I try to finish my presentation. So, but yeah, so the first 3 presentations, at the beginning I was thinking what to do. So I needed to separate them, put it into one, and it made a hell of a lot of sense to actually have one large presentation, because they're all 3 papers are complementary. So my name is Argo Picas. I'm a PhD student in the joint PhD program between Tallinn University of Technology in Estonia and the Aalto University. And it's basically my last year, so I have started to write out my thesis. I still have a few case studies to run and finalize them. I'm in the middle of writing it down now. So, and today I would like to present my work about design and design process model development. And it's maybe a further development than I had in my papers, because it's been a long time, half a year, when I submitted my papers. But we have just continued doing work, so I'm trying to present something new as well. And therefore, I hope you bear with me. So let's move on. Let's move to the introduction. Design is ubiquitous. Everybody designs sometimes, and nobody designs always. Just think about when you cook a meal. You're actually what you're doing. You're designing. You have to consider what is your goal, and then you have to work backwards. You have to think about what are the means, what are the methods to achieve the result, the goal. So design is essentially a cognitive task, and it's a reasoning process. And reasoning is at the core of design thinking and activity, as Richter said in 1997. And considering that design is a ubiquitous concept, it's interesting that it only got more extensive attention in the 20th century. Before that, it wasn't considered as important. And more interesting is the fact that it was only in the 20th century when the new contemporary design conceptualizations, they often reflect the historic view and evolutionary view of the design knowledge, the design practice. What I'm going to argue is that we have some ancient methods which we can use to display in the engineering design and design thinking. So, but first, so in this design office, what we need, in order to go through the main information, we need to step back. We need to step back and we need to look at the design office and the design process from the holistic perspective. We need to understand how the whole as a system works. Yes? And then from there, we need to look at the next level. The next level in terms of the prevailing paradigms and obstacles. These existing paradigms, we need to reveal them, and we need to understand them, and we need to understand the basic assumptions and foundations to attack them. And that's what we've been trying to do. So, I think it was already in 2006 when Lowry and his colleagues wrote the first paper about prototypic design, which basically is a method of analysis. And it's based on the ancient method of geometrical problem solving. And what they have been arguing is that, even though the contemporary design conceptualizations have forgotten this method, it's the best knowledge that we have from the ancient time in terms of how people reason in a rational way. And the other method is rhetorics. And so they have been arguing that you can use those 2 conceptualizations to describe the engineering design process and design thinking, and the way the architects and the other designers think. And both, obviously, they fall into technique, which is the production side. So it's basically saying that design making cannot actually be separate. They're complementary. And it kind of seems like a revolution, but in the beginning of the 20th century, Taylor said that before you do anything, you have to think first. But it was already Aristotle who said it more than 2,000 years ago that before you do anything, you have So nothing new in that. So, as I said, method of analysis represents the necessary rational reasoning and then the rhetoric to the plausible reasoning. And what these mean, we'll see later. But the main hypothesis in this research is that in order to manage design, you first need to understand design. You need to understand its constituents, the way engineers design this thing, work, etc., what kind of means they use to extend their cognitive capabilities, reasoning capabilities, and etc. It's an interesting field. So going to the problem statement, the overall problem statement is that we have 4 conceptualizations of design, and these 4 conceptions of design, I think, is represented in the fact that most of the design management is basically project management. It's focused on the transformation view of operations. So executing to defining a breakdown structure and just controlling that everything goes platforms. And it's interesting, you know, I'm coming from more from the making perspective, because in the past I worked in construction companies and for supervisory companies, and I found it quite peculiar that when I started studying or learning about design, that actually the design managers, based on the person managers, they work exactly, they think exactly the same way as the making process. And I found it interesting because there are completely different ways of thinking about it. One is knowledge-intensive task, and the other one is just following what has already been established. So going from there, and I think this core conceptualization of design is visible in the different life cycle models that have been proposed here and there. There are many other more models, but it's interesting that, you know, despite all these models should be representing the same phenomenon. Yes? It's about the same thing. We're designing buildings, facilities, infrastructure to meet the expectations and the needs of the users and the customers. But for what reason are they so different? That's the question. And that's probably because they have so poor understanding of the basics or the foundations of the design. So going forward to the research method, I've employed here as a constructivist research approach, more particularly the design science research, because it makes a lot of sense. I'm trying to develop a design across the pond. And it is, from the other perspective, it's necessary because you know, in productive sciences, as we are in, yes, we can not use the same methodology, same methods to study the phenomenon that you would do in natural sciences. They are, by nature, different things. So the goal is to develop scientifically grounded solutions that are able to solve problems with practical relevance, also, which is the purpose of the design science research. Papers were divided into 3, and as I said, they were complementary. So the first paper was studying and understanding the environment. The company describing the current practices, but also what are the problems, and therefore also opportunities. So that was the focus of the first paper. The next paper was about developing or establishing the foundation in terms of the concepts. And I was particularly focusing on the 2 pillars of design, which is the method of analysis and the rhetorics proposed by Glenn and Laurie. But I was comparing also the other design conceptualizations. You know, basically there are as many design theories models as there are design theoreticians. And some even have 2 because sometimes they change their mind. So it's quite problematic. And the third paper was trying to take all these 3 papers kind of together. So it was a design cycle. And their first cycle included the development of the conceptual design methodology and its evaluation. And then the second step in the third paper was its implementation or instantiation in practice. So first, about problems in the design of this. This company has been using ERP system for the last 8 years. But the way to collect data and track their hours of work was very poor. So it was really difficult to understand what actually, based on the data, it was really difficult to understand what's actually happening in the design process. So basically what they recorded was that, you know, when the designer or architect or engineer was working in the preliminary design stage, he just said, I'm working on preliminary design stage. Therefore, based on this data, it seemed like 52% is like a value-adding activity. No one one believes it. So I went on, we observed the design project over 8 weeks. We had a master student following all the designers and engineers and asking them why they did what and how and etc. etc. And then basically we understood, okay, you can divide this 52% into another 57% for like design activities. And the red one, 20% for the exchange of information, so just communication, emailing, things like that, which is very important part of design, absolutely. You know, you have to come to agreements in terms of what are the means we're going to use in this project to meet our goals. But the problem is that, you know, we did a small intervention to make our data collection easier. We put them into co-located space. We didn't do anything else. We just put them into co-located space. But because they weren't used to talking to each other, they actually didn't use this opportunity to, you know, avoid problems. But they became very good problem solvers, you know, because when they sat together, it was easy and very fast to solve problems. And further on, so what's this 57%? You can see that there are so many different things. One would argue, of course, it's not correct and it's not direct. It's very hard to measure the value-adding activity in this design stage. But one would argue that the value-adding proportion is somewhere between 10 to 20%, not more than that. In company, they had a large variability. You can see that in most types of the projects, they spend more time designing than they had initially estimated. And only in 3 types of projects, they spent less. And in the industrial and warehousing project, they spent less last year only because they basically did the copy-paste from one project to another, and they saved like 60%. And that skewed a little bit the numbers. But in average, they spent 14% more time on every project, basically what they do. This is where the company as a whole spends their time. And you can see that they spend their time on producing drawings and models in design, development, and construction documentation. You know, having people coming to it. Basically, you don't have nothing in the schematic design. And the other disciplines are not almost involved at all in the schematic design phase. And in the preliminary design phase, what the engineers typically do, they just write a descriptive specification. They don't even sometimes a model or draw it. So I went further, I took all the 28 projects and I categorized them into 3 different groups. Here you have 2 other groups. And I picked out 12 projects where they had all the 3 stages. And you can see basically it confirms the previous numbers. They still spend most of their time in the design development stage. And the same is with the projects where they had all 4 stages. This is a time distribution of different disciplines by color and by different activities. So obviously designers work mostly, is there a point of view? No. Okay. So most of the designers work in the design, but the project manager, which is the dark blue, is taking care of the administrative stuff. And project manager is spending half his time in the middle. So this is the mechanism basically for the control of the design process, which is, I think, very important. So then we took same data to understand so what happens, what is the typical life cycle of the design process project. And you can see 2 curves. The gray curve shows the projects that were in net loss after the project ended. I mean, they lost money on this project. The gray curve. And the blue one shows the typical curve resource consumption for the profitable projects. Not too much different, but you can see that the leg like extending after the contract deadline. So here we got the average contract deadline for different projects. Yes? So they spend pretty much the same amount of time after the contract deadline, which is quite a lot. And this is one of the main installations for the loss, basically, in terms of the money and everything else. So that means they have lots of errors and problems in the design projects. And if you would compare this to a previous curve, of course, it's idealization. Yes? gives us kind of like a reference where we want to go. We see that this curve should be, you know, we should push more work to the front of the design process, have people coming together, you know, align their interests, align the ways of strategies and approaches. But obviously still have something after the design concept deadline, because there might be some, you know, small fixes, changes, there might be some, you know, copy of, you know, architect has to come on the site to confer this or the other material or develop things like that. So you can't, I don't think you can actually fully complete before the concept deadline. But that's not the point. So now when we compare what's happening in terms of communication, you see this line here, this line. So this is the project manager. You can see that from vertical, if you look at vertically, this is the guy who sent the email. So we analyzed emails and the database of the emails. And you can see that 50% of all the emails were sent by project manager or were received by project manager. Yes? So it's very important. The communication overall is very, very important. And what happens is, you know, you have a project manager, he has 6, 7 projects. And if he has to be like a, you know, like a pigeon messenger, in all of these projects, you can assume that he cannot actually focus on the content. He has to just, you know, he's the guy who's just sharing and translating and saying the information to this. So there is no control over the process. So in conclusion, there were many problems. Importantly, design management is concerned with task and resource management. Focus is on producing drawings and models, as you saw. Then late changes in patching, which is very difficult in design. A lot of iterations, negative iterations, bad iterations. But you can, I personally believe that you can avoid at least a good portion of them by having a good design process. And then you have ongoing work scopes. As you saw, you know, it's very typical in Estonian design office and practice that the architect starts alone without having any conversation with the other disciplines. He's making assumptions about, okay, what kind of columns or beams or what kind of, you know, MEP systems we will use in this design. And then what it leads to is it leads to many, many problems. It leads to problems in terms of if it actually can be done, it can be. So you necessarily want to avoid this. Well, obviously, we try to do the root cause analysis, but I think the most important is that there is an oversimplification, trying to approach the design in the same way as we're doing the construction project. And in sum, I would say that the traditional project management was the only visible framework in this design platform. So a little bit about the theoretical background. I'm not going to go through all the different concepts and conceptualizations. I'm just going to say that this work has been formed by so many different models, and including systems engineering, of course, transformation flow and value, which is the foundation for reconstruction, as you know. Then the 2 pillars of design, domain theory from Denmark, geometric design from MIT professor. They all have some interesting contributions. And here is a summary of different conceptions, based on the different conceptualizations of design, which is the rhetoric and the logic design. Both of these have different starting point. They have different ways or types of reasoning used, and then different methods and different focus, of course. So, but most importantly, and now I want to go move on my slide.
10 minutes.
10 minutes. So, most important, I would now like to share my model. And in a big picture, what we can do, we can divide the design and make it into 2 streams. Yes? And the first stream is the analysis, which basically, in other words, means design. Yes? And the other one is synthesis, making. What next you can do is that you can divide the design into 3 overlapping circles. Inside, you have outside, the most outside system is the design system we design within. That typically includes the local community, local authority, the company, the school. You know, if there is a local government who wants to develop a school, they have to consider what is the concerns, targets, objectives of the local community, what they need, why they need. Yes. So you have to consider those aspects. And all design always takes place in context. You cannot take the context away from the design space. Then there is so if the first one was a local, global environment, then the next one is the local environment. And it's basically from the perspective of the users and the customer. You want to understand how the customers, users, want to use this facility in order to achieve the goals. Such as, you don't design, it's very important, you don't design buildings for the sake of the building itself. You design the building, which is either the school or a healthcare facility, for the purpose of using it for teaching kids or healing patients. So definitely you have to consider that. And what is the basic is that, what this, the system is designed for is facilitated by system of design. So this is the artifact itself. It's kind of like a resource for achieving our use objectives or use functions. Yes, and this helps to achieve our goals. So we have 3 embedded systems, and the system of design is the inner circle of these different contexts. Overall, we can divide into 2 polarizations. So on top, we have real, so it's empirical, the way we experience the world, the way we understand the situation. And at the bottom, we have symbolic. So we basically design, we use drawings, we use models, we use calculations. These are symbolic. We use basically representations in order to extend our cognitive capabilities. It's kind of like it becomes a memory for what we're thinking about. And then on the left, it's subjective, because most of the analysis and the design happens in the heads of the designers, engineers. And when you are communicating from left to right, which is from analysis to the synthesis, you're going to the objective way. So you're communicating your ideas, your message, through the encoding to the material, to the medium, basically. We can divide these 4 contracts into, you can give so many different names. In design thinking domain, we have, like I said, every design researcher has their own model, and they name it differently, but basically it's the same thing. So I've just called them discover, define, develop, and communicate your design, based on the rhetorics and prototype of design. So what is the first step of statements? We need to recognize there is a gap, there is a need for something else, and typically it comes from the customer perspective. So we need to build, for example, an real estate developer, and let's assume I have a land in downtown Tallinn, I need to consider, okay, I have money, I have property, so therefore I have a need to make use of this money and property. So I recognize the gap, and then the process is the line itself. So you're going from one state, the identification of the gap, to the targets. You can say that it's basically, the first step in target is establishing your goals. And the process of going from gaps to targets is following the rules of reasoning types of transformation, regression, decomposition. Transformation basically means you're transforming the problem from something to something else. Like in school in the past, we had text-based mathematical problems. Now you had to convert them into algebraic equations, so you could solve them. So it's a transformation. And regression is you are thinking about what are the needs. If our goal is to reach near zero energy building, I immediately know I have to use some kind of renewable energy on the site. Without that, I cannot do it. But of course, we have different needs. And that's the reason, when we ask different designers to design the same goals, they design different things because they perceive things differently and they have different views on how something can be done. So once we have established our goals, we go to the design, some call it design criteria. Glenn has called it a design criteria, and it's a lead project delivery model. But basically the phenomenon we are trying to capture is what are the user needs? What are the goals of the users? If it's a hospital, we need to understand the movement of the patients. We need to understand how the doctors, nurses can support this movement and provide the best service by using the facility. And of course, this process follows also the transformation, regression, and decomposition. didn't mention about the decomposition, but it's basically when you have decided, okay, I'm going to use renewable energy, I'm going to use solar panels, for example, then you immediately know that you have to have these components, right? You have to have panels, you have to have a system that converts energy from, from one type to the other type, which is called the names, something like that. But basically, this is what you do. So once you have the understanding of the targets, you have the conditions of satisfaction, the user needs, use functions, and the use properties. If I want to color my car, if I have a business, I want to color a car in that specific space. I need to think about, okay, this space probably has to be hermetic. It has to have a separate ventilation system. And so, as you can see, all these requirements are deriving from the needs of the customer and the user. So, the next step, we are going from the system we designed for, we are to the system of design. So we're going from one perspective to the other perspective. So if you have your phone, basically if you're a user, you're seeing only your interface of the phone. But then you go inside the phone as a designer and as an engineer. Now you want to understand how can I facilitate those use functions by designing some kind of system or structure. And as I said, requirements. These requirements can be on a high level, they can be on a detailed level. It depends what you're trying to capture and in what stage of the design you are. And then we have talked in the sense that we address, okay, if the requirement was reusability, then I already immediately know that in cold climate Finland or Estonia, I need to use optimal passive strategies, for example, called the envelope. You can't use a glass box, it doesn't work. It's not possible to use actually reusability. And then I have to use renewable energy. Okay, so these are the strategies. So how I can achieve that? Okay, I have alternatives for the windows, for the walls, I can use sandwich, I can use whatever. Yes. But as you can see, this process is not linear. We always say that design is iterative. And this is what this model is showing, that analysis actually is iterative. It's not rational as often we think, especially when we're talking about analytical populations and things like that. So you have iterations, and you have iterations in the left hand, you have iterations in designers and engineers' head. So what happens next is, now once you have reached the end, which in the case of the CPA, shooting by lenses, means that you have to find about alternatives. So what is the next step? Attributes? Yes, you define your attributes. So you have to define your properties. Like if you are in Revit and you're modeling a building, you have to define what are the properties of the instance. Yes? You have to decide what are the dimensions of the column, what are the dimensions of the beams. So basically what you're doing, you're going from subjective domain to the objective domain, from your head to the actual material medium, to representations. And at every step in the left or in the right hand, you are verifying your step against to the left side. So if I wanted to design a column and beam, I have to verify if I actually met the order I did. So what is the next step? Inputs. This is a question to you. Assembly. You need to go from the instances to the assembly of the design. If I'm a structural engineer, I need to think about how my columns and beams fit together. But not only, I also need to think, if I'm a design manager, I need to think how different design disciplines models come together. And I can do class detection, I can do class resolution processes. And this step is called, cognitively, it means composition. We are thinking in our heads how we can compose some elements together so to have achieve our goals. But physically, it means assembly, just like in construction. And also there, of course, we need to verify. And the verify is basically answering to the question, did we meet our goal or did we didn't? So it's more like a yes and no answer. Then the next step is a deduction and the testing. So we use simulations, for example. Yes. We use simulations, and then basically, if I had a requirement to meet the leaders energy classification, by the end of the design, if you use the models, you can do the simulation, and you can decide, okay, I met it or I didn't met my goal. And this is inside the design, like inside the structure. But now we're going back out, and now we're looking at the artifact from the user's perspective. So it's about evaluation, understanding, is this artifact or the design solution that the designer has proposed, is it meeting my goals or it doesn't meet my goals? Does it help me to meet my goals? It doesn't. And the funny thing is that it's not funny. The interesting thing is that system of design, you can consider it as more like a rational process. But eventually, when you go out from the system of design to the system we designed for, you have users, and users have different experiences, perceptions, and they can just easily say, I don't like this color. Then change it. Yes. And of course, the next step is the understanding, when the building is in use, we need to understand that is it meeting our goals or is it not meeting our goals, the long-term goals. Are we having the return on investment that we have or not? And the design should finish with satisfaction. So I'm going to run through of the different slides quickly. So as I said, there are many design theoreticians. They have given so many different names to these things, but for most design models are black boxes. They don't describe what is actually happening in those different stages. They just say that we go through the discovery, define, develop, and delivery stages. And these are iterative, yes, the cycle. Not very helpful. Then Agile, software engineering, the same thing. Analyze, design, code, test. Or another one, explore, generate, evaluate, meet. Many examples. The best one I know now is probably the B model from Christian Liquid and the other guys who did the work in 2014, who showed their work in 2014 and 15 at the IGLC. And it probably comes closest to what we've been or I've been doing. And that's quickly about the characteristics. So there are many ways of going through this model. Expert designers, they jump from, typically what they do, they jump from requirements or understanding of the customer needs users to the design methodologies. And they rather focus on the synthesis making and try to verify through the synthesis that they're actually meeting the required goals and objectives. While the novice designers, what they do, they work backwards. They try to think very systematically because of the lack of experience. This is from the chaos theory, complexity theory, and what I'm claiming is that because this is a design meta model, the same model represents basically the process on many different levels, on the entire life cycle, but also on the individual design working on his own tasks. Because he needs to go through these different steps, he needs to think about what are the goals, who are the users, what are the needs, requirements, how can I achieve my results, what are the alternatives, and then making it. So the same thing. This I already discussed, so it's just design is about some extent about predictions. You're trying to understand how we can make things in the future, while science is studying the existing. Design is about aligning different views. This is what makes it complex: the customer and the user's perspective, but also the perspective of producer making, but also the operations and maintenance, and that's what makes it complex. And what flows in design or analysis is information, and in the synthesis is material. And this is not new for the lean community. We know that. And here are just some instantiation. So we have used this theoretical model now to develop a high-level process model, and up to the third process level model, and with different activities, inputs, outputs, and now used the high-level process and the process model to indicate what tools, methods can be used in every step or every stage in the phase. And we are now in the middle of developing metrics for different phases and stages. And we redesigned the whole organization. So if before we had departments, now they have a flat organization, and they only have disciplines. And the bonus system is aligned. Checklists. And this is a work that we did Tamiran. It's integrating LOD, goal planning, ESM, and that's the conclusion. So thank you very much. Just a few words about the conclusions of the concept. The board conceptualization of design has actually lead to board practice. And then intuitive elect and board conceptualization of design. There are so many different models, and that's probably one of the instances. Method of analysis and rhetorical architectural arts applicable in many different domains, no matter the subject matter. And in order to manage design, we need to understand this. Thank you. Quick task, everybody. Solve it quickly. What's the answer?
Okay.